So the next topic is the MPEG immersive video. I believe this might also be related with your interest about the dense light field. So, but MPEG immersive video try to compress the multiple view video content to describe the 3D scenes. It may include texture only, multiple views, or texture plus depth multiple views. The main challenge for the application is the higher pixel rate as well as a higher bit rate, because the large number of views. Another limitation we are asked to consider about is we'd better to reuse the existing 2D video codec to support such a 3D thing, content compression. So in the design of immersive video coding in the MIF encoder and decoder, actually we pipeline the system into the pre-processing of those multiple views, try to organize the textures and depth informations into, we call that atlases. And those atlases can be compressed with existing video codecs, such as HEVC codecs. And additional to that, we also need more information to describe the information in the new generated atlases. So by using such a framework, we can achieve here I provide some numbers in this size as an example. So the input data rate could be dozens of gigabits per second. After this processing, the pixel rate can be reduced to no more than 1 8K video, and the bit rate could be in the range of dozens or no more than 100 megabits per second. And so for the details of the procedure of the encoding is we use the view projection to try to find out which are the redundancy between the different views, and find out those, let's say, occluded areas in the, let's say, the basic view, but not in the additional view. So only those occluded areas of the additional views will be included in the packed atlases. So as I just mentioned, the metadata actually are used to define those packing information. So which patch in the atlas is come from which view, from which position, and the camera parameters of each views, and so on. So the packed atlases, actually it's a dynamic video, so you can compress the atlases sequence with existing video codec for both the texture as well as the depth information. And the multiplexed video bitstream as well as the metadata bitstream give us the bitstream of MIF. Actually, this pipeline is quite similar as point cloud compression. I mean the video-based point cloud compression. So we share the same framework and the same framework for the syntax. So that's the video-based volumetric video visual media coding, the V3C. So MIF actually is based on the V3C, but in order to decode the MIF V3C bitstream, we still needed to have our own standard to describe how to reproject the patches in the atlases, in the decoded atlases, to the source views, and so that those source views can be used to synthesize to any virtual view you want to watch for the 3D scene. So that's MIF. And the FDI, we already reached the FDIS for the first edition in October. And from several meetings ago, we already started our work on the second edition. In the second edition, there are more functionalities as well as some new features, such as we can have more flexible camera settings. Those camera settings can also be dynamic, and we are trying our best to well handle surfaces exhibiting non-Lambiscian characteristics, such as in these two sequences, there's a mirror, and there are the glasses and so on. So we hope we can have a better support on such kind of thing. And we also try to support the combination of heterogeneous content, such as video-based multi-views and point clouds in a single V3C bitstream, or even in a single atlas. So that's new functionalities we are working on in the second edition of MIF. So next topic is not yet a real standardization project yet,